Hey family members, it's Mr. Panza. As I sent out that last video, I just realized that I didn't really give you any instructional tools on what the students have been using for long division. The main question that we've been asking the students is how do we divide using a method such as repeated subtraction. Many of us are typically used to seeing a division question that looks like this, 2,560 divided by 8, and using a 5-step process to divide. Meaning you set up your division with 2,560 inside and then organizing your 8 outside, which it will still look the same, but instead of dividing first, how many times does 8 go into 25? 8, 16, 24. It goes in 3 times, then multiplying. 8, 16, 24, and put the 24 under here. Then subtracting. Subtract 24 from 25 to get 1. Then bringing down. Bring down your 6 to get 16. Then repeating the whole process again, we used a 2-step process known as repeated subtraction. I'm going to teach it to you now, and I hope that it is helpful for you. So in the same exact problem, I have 2,560 divided by 8. So really what I'm asking myself is how many 8s can fit into the number 2,560? You're trying to group 2,560 in equal groups. How many 8s can fit into those? So I need to ask myself, how many times 1 times 10 or times 100? And I'm multiplying either 1, 10, or 100 by 8. So the 2-step process is 1, I'm going to multiply over here, and then 2, I'm going to subtract inside. So 1 is too small, 10 is too small, and 100 will fit the bill. So I'm going to start out with 100. Now, 100 times 8 equals 800, and I could certainly do that and subtract 800, and then 800 again, and then 800 again. But what we've been telling the students is, instead of just doing 800, how many 800s can fit in to 2,560? So we taught them how to skip count by 8 as close as they could get to 25 without going over. 8, 16, 24, then they stopped. Because they got to 24, they didn't want to go over. But that tells them something. 100 is too small. We could actually instead replace the 1 with a 3. And instead of just taking 100 out, you take 300 out. Now this is where some of the students got stuck, in which case we told them just continue to take out 100. In this case, you'd have to take out 800, subtract. Take out another 800, subtract, take out another 800, and subtract one more time. But a student that understands repeated subtraction is going to realize that it's not just 100. I'm eventually going to take 300. And when I multiply 8 times 300, I look at 8 times 3, which is 24, and I add my 2 zeros. So my first step was to multiply. Now I subtract. And when I subtract 2,560 and 2,400, I'm going to be left with 160. So I can no longer take out 100, because if I did, I wouldn't have enough in there to subtract. So I move down. My next place value is 10. Again, I'm multiplying 10 by 8. But what's great is I don't want to just take 80. I could take 80 out, but then I'd have to do it twice. So instead, I'm going to get rid of my 80 and skip count by 8 to see how many 10s there actually are that I can fit into 160, or 16. 8, 16, then I stop because I'm there, which then tells me that instead of this being 10, it's actually 2 or 20. And when I multiply 8 by 20, I get 160. Now I subtract. Now that I'm down to 0, or if you get to a number that would have been lower than 8, this is your remainder. How do you know your answer then? Focus on the standard form version of the number that we've now created right here. I have 300 in the hundreds and 20 in the tens. And the students learned in place value that in order to take those two numbers, you just add 300 plus 20 to get a standard number that we put as our quotient. 320 is our answer. I could check it as well. If I take my quotient, 320, and I multiply it by my divisor, 8. If you plug that into a calculator, I've used multiplication to check division, which would get me my answer of 2,560. Other one. 1,080 divided by 2. When I set up 1,080 inside my division box and 2 as my divisor on the outside, I need to start asking myself what I'm really doing when I'm dividing. I'm asking myself, how many times can 2 go into 1,080? Or in other words, how many 2's are there? So I've got to ask myself, when I multiply, everything is going to be times 2. So that's either going to be 1 times 2, 10 times 2, or 100 times 2. Well, the smartest one to go with is your highest digit. We can't do 1,000 because 2,000 would be too high. So let's start with 100. Only I don't only want to take 100 because I can get close to 10, which means when I skip count by 2, 2, 4, 6, 8, 10, I notice that I can fit more than just 100 in there. I can actually fit 500 inside of 1,080 because when you multiply 500 times 2, you get 1,000. Now that I've multiplied, my next step is to subtract. 0 minus 0, 8 minus 8, and now I repeat the same process, only this time I can't multiply by 100. I have to jump down to the tens. Notice how I'm using the chart paper to keep myself organized so I can eventually add this correct in the right place value. So 10 times 2 would certainly work, but think about how many times you would have to take 10 to get to 0. Instead, I'm going to skip count by 2 to get up to 8. 2, 4, 6, 8. So this 1 instead could be changed to a 4 because there are actual 4 10s that can fit inside of 80 when I'm multiplying by 2 and asking myself how many 2's can go into 1,080. So when I multiply 40 times 2, I get 80, and I subtract, and I get 0. Now, I take the information that is in expanded form over here, 500 in my hundreds category, plus 40 in my tens category, and I get 540. So this is a method of division that maybe you've never seen before. But in short, it's a way that you can use repeated subtraction to divide. I hope this helps, and I'm sorry for any confusion.